So, the problem is a 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of a 0.157 concentration solution of calcium hydroxide. What was the concentration of hydrochloric acid in the original solution? So what we're looking for is the molarity of or concentration of hydrochloric acid in the original solution. So the first thing we want to do is write out the balanced chemical equation seen here. That way we can use this information later on throughout the other parts of the problem. So when you write the balanced chemical equation, you get 2 moles of hydrochloric acid with 1 mole of calcium hydroxide yields 2 moles of water and 1 mole of calcium chloride. So once you write this out and balance the original and balance the chemical reaction, the next thing you want to do is kind of write out the problem and write out the given information beneath it. So for example, here we have 2 moles of hydrochloric acid. So since this ionizes completely, you want to separate into ions, and then you want to write out the given information from the problem, which we know is 75 milliliters. And then for the calcium hydroxide, this ionizes as well, and so you want to write out the given information beneath that, which is 27.3 milliliters and a concentration of 0.157. Now, since we're looking for the concentration of hydrochloric acid, you just write that question mark, that way you don't forget throughout the problem what you're looking for. Now, since all the given volumes are in milliliters and concentration is moles over a liter, we have to convert the milliliters to liters. So 75 milliliters becomes 0.075 liters of hydrochloric acid, and 27.3 milliliters becomes 0.0273 liters of calcium hydroxide. So now that we have all our given information and in the proper units, we want to write out what formulas and relationships we're going to need to solve this problem. So we know that molarity equals moles over volume, and if you manipulate this, you can know that the molarity times the volume equals a number of moles. So since we have both the molarity and the volume of calcium hydroxide, the first thing we're going to do is to convert the calcium hydroxide into moles. We know that molarity times the volume equals number of moles, so take the given number of moles, we take the given molarity, multiply it by the given volume, and that's how we find the number of moles of calcium hydroxide. From there, we then use stoichiometry from the balanced equation to find the number of moles of hydrochloric acid. So we use the given number, or the number we found of moles of calcium hydroxide. We multiply it by the molar relationship in the balanced equation, which is 2 moles of hydrochloric acid for every 1 mole of calcium hydroxide. And from there we get this number of moles of hydrochloric acid. So once we found that, we now have all the information we need to solve for the concentration of hydrochloric acid. We have the volume and we have the moles. So using the equation molarity equals moles over volume, we can then plug in the number we found for the number of moles of hydrochloric acid over the given volume to find the final answer of 0.114296 molarity of HCl. And then one thing to keep in mind before you start any of this problem is that this in fact is a titration and not a dilution. One way that I use to realize this is that when you're working with a dilution, an external compound is not going to be added. It's going to be some compound added to water, and your volume's going to change. And then on top of that, and if your volume changes, obviously your concentration changes as well, but the number of moles of the compound stays the same. And then a titration, it's going to be some compound added to another compound and you're gonna have to use stoichiometry most likely to solve for something. Yeah.